The first day of our second unit here in geometry, we're going to be dealing with angles. So this whole unit is all about angles and parallel lines and relationships that they share and the common congruent angles and all sorts of angle addition postulates that we can be looking at when it comes to having parallel lines cut by a transversal, auxiliary lines, linear pairs, adjacent angles, all sorts of different types of angles. So to start off with, we're just going to be looking at angles and the different types of angles we can have when I have two angles to work with, or at least two angles working with. The first type of angle we're going to look at is an adjacent angle, and these are two angles that are in the same plane sharing a common vertex and a common ray, but no common interior points. So this essentially looks like this. So here we have one angle, and here we have a second angle. So angle 1 and angle 2 here. These are adjacent angles, basically next to each other. This ray in the middle is all that they share, but that's it. So adjacent angles, if we know the full measure, we can add them together to get the full measure of the entire angle from our bottom side to our top side here. Other than that, unless we know more information, we can't really add them together. It's just more of a the whole is equal to the sum of its parts type of situation. Now, a linear pair is a little easier because it's two angles together where they will form a straight line. So here we have a straight line. Again, we have two adjacent angles. So here we have angle 1, and here we have angle 2. There's nothing in common aside from the center ray, but if I were to add angle 1 and angle 2, I'm going to get 180 degrees. The complementary angles, two angles measures that have a sum of 90 degrees. So this is, I end up with a right angle. Again, adjacent angles. So we have two angles side by side here, angle 1, angle 2, where you don't know that they're congruent, but if they tell you they are complementary, that is language for they create a right angle. So in this case, angle 1 plus angle 2 is going to equal 90 degrees. Supplementary, it's very much like the linear pair. Supplementary angles will add up to 180 degrees. So here we have a straight line. So here is our adjacent angle, angle 1, angle 2. Again, same deal as up above with the linear pair. If I add angle 1 and angle 2, I'm going to get 180 degrees. The angle addition postulate basically says if I add two adjacent angles to form the whole angle, the whole is equal to the sum of its parts. So that's something I say quite frequently in the classroom. The whole is equal to the sum of its parts. And this works for segment addition. It works pretty much any type of addition. I add up the parts, I'm going to get the whole thing. And then the supplement theorem states if two angles that form a linear pair are supplementary angles, pretty much as stated up above, supplementary angles, they add up to 180 degrees. And the supplement theorem states if I have a linear pair, they're supplementary, add up to 180 degrees. So for example, we need to find the measurements of these different angles. A, B, we know A to B is a segment, it's a linear, it's a line. We know lines add up to 180 degrees. So we know from here around we're going to get 180 degrees. So this means all I have to do is add 144 plus A, and I'm going to get 180. So I'll subtract 144 from both sides, and I get A equals 36. So 36 degrees is going to be the measure of angle A. Number 2, we have to find the measure of angle F. Again, we have segment AB, so we know this segment is going to be 180 degrees. So we are told this part is 72 degrees. We have a little square in the corner, so this tells me we have 90-degree angle, and over here we have F degrees. So going with the addition part, if I add everything up, I'm going to get 180. So we have a 72-degree angle, a 90-degree angle, and F, and I'm going to get 180. So step 1 is to combine our like terms. 72 and 90 is going to make 162, plus F is going to give me 180. So I'm going to subtract 162, so we can get F equals 18 degrees. So right now it's nothing extremely fancy, straightforward all the way around. Just adding to find our missing angles. So again, 3, find the measure of angle C. So here we have segment AB. We got 40, 36C, and right angle 90 degrees. So we know the whole way across is going to be 180. So we can add all our angles together. 40 plus 36 plus C plus 90 is going to give me 180. So I want to add 40, 36, and 90. Well, 40 and 36 is 76. Plus 90 is going to give me 166 degrees. This is going to give me, and when I add C to it, I'm going to get 180 degrees. So I'll subtract 166. So we end up with an angle measurement of 14 degrees of C. Now this next problem, number 4, is a little bit different because it does not form a linear pair. We have an angle here. It looks like it's slightly off. We have angle measurements of 2x, x, 85, and 35. So we do not have a linear pair here. But again, general rule, if we go around the whole way, if a line is 180 degrees, which is halfway through a circle, if I go the full way, I'm going to get 360. So again, we remember that a circle is 360 degrees, kind of like snowboarding or skateboarding. If I go once the full way around, it's 360 degrees, part of their tricks. So if I add up all these angle measurements, I'm going to get 360. So 2x plus 85 plus x plus 35 is going to give me 360. So we'll combine our like terms. 2x and x is going to give me 3x. 85 and 35 is going to give me 120. Gives me 360. And now at this point, we're just going to solve for x. And that is ultimately our goal. Find the value of x. So subtract 120. So we get 3x is equal to 240. And when we divide by 3, we get x equals 80. So the value of x is 80. In this case, we could say this angle is 80 degrees. Number 5, being a word problem. Everybody loves word problems, so we got to take it. We got to look at what they are asking. We are told we have 2 angles that are complementary, and one angle is 6 less than twice the other angle. Find both angles. So step 1, angles are complementary. This means they are going to equal 90 degrees. So now what we want to do is we want to take a look at the relationship between the 2 angles. One angle is 6 less than twice the other angle. So twice means we multiply the other angle times 2. So what we're going to do is, since we don't know what the angles are, so we're going to identify the first angle as x, since we don't know what it is. And now we look at what the relationship is. 6 less than twice. Well, twice means we multiply the other angle times 2, so 2 times x, and then 6 less, that means I'm going to take away 6. So 2x minus 6 is going to be the second angle. So again, complementary angles means if I add up the two angles, I get 90 degrees. So our first angle was x, and our second angle was 2x minus 6. And we are going to be equaling 90 degrees. So we're going to add x and 2x, so we get 3x minus 6 gives me 90. Add 6 to both sides, so we get 3x equals 96. Divide by 3, and we get x equals 32. So the first angle is 32 degrees, and then our other angle we said was 2x minus 6. So 2 times 32 minus 6, so we get 64 minus 6, and we get an angle measurement of 58 degrees. So one angle is 32, the other is 58. If I add them together, I will get 90. So we are solid with our answer. Now when it comes to some crossing lines, so if lines cross, we end up with 4 possible angles like here in our example in our first one. Notice we have 1, 2, 3, 4 different angles that occur when I cross two lines. Now something funky kind of happens when I do this. I end up with what's known as vertical angles. So these are two non-adjacent angles formed by two intersecting lines. So essentially, if I have a line coming this way and I have a line going this way, non-adjacent. So adjacent again means next to. So non-adjacent means they are not next to each other. In other words, they are going to be across from each other. So I could say these two angles here are my vertical angles. At the same time, the other pair are going to be vertical angles as well. So again, vertical angles are going to be across from each other, and a cool thing happens when I have vertical angles that helps us out in the long run when it comes to problems is the vertical angle theorem that states vertical angles are congruent. So if I were to draw two lines here that cross, this means this angle and this angle are the same. They are congruent. So I can use measurements to figure out values of x and find the value of the missing angles. So I'm going to skip the first problem because it deals with factoring, and I don't want to, it gets kind of confusing with factoring. I want to get more into the gist of things. We need to find the value of x and y. Now we can do this a couple different ways. A to B being a segment is a straight line, so we can add the angles together to get 180, or we could have vertical angles here and set them equal to each other. My suggestion on this, because it's going to be easier, is to add the two angles here to get 180 since it's a linear pair. So we can say y plus x. When I add y minus x, I'm going to get 180. So if I combine the like terms, y plus y is going to give me 2y, x minus x will go away, and I'm left with 180. So I'm going to divide by 2, and I get y equals 90. Now we can use this to our advantage because now we can have our vertical angle theorem. I can set my 2x equal to y minus x. I now know that y is 90, so all I have to do is substitute it into my problem. So I end up with 2x equals 90 minus x. Now I want to solve for x, so I'm going to add x to both sides because I have a solid number on my right hand side now, and the x's will cancel out. So 3x equals 90. If I divide by 3, I'm going to get x equals 30. So 90 and 30 are my x and y values, and we have solved our problem. So now number 3, I start adding a few things. It says find the value of each variable. In this case, problem number 3, the only variable we're dealing with is x. We got an angle measurement of x. We got an angle measurement of 4x minus 10. And we are told we have a right angle here, which is 90 degrees. And we need to figure out what x is. So how do we do that? Well, we don't have any adjacent sides that are labeled. So now we go to the vertical angle theorem, which states vertical angles are congruent. So if I look at C to D and A to B, this angle here, x, is going to be the same as the one across it. So here we have x, and then here we have the angle measurement of 4x minus 10, which means the angle across from it, which is over here, is also going to be 4x minus 10. So now we have enough information to figure out what the value of x is. So if this angle is 90, this angle here is also going to be 90. So here we have the angle 4x minus 10 measure and the angle x measure. They are complementary. So if I add them together, 4x minus 10 plus x, I'm going to get 90 degrees. Because here we have a linear pair. This section is 90, which means the bottom section here from F up to the intersect over to D is also 90. Combine like terms, 4x and x makes 5x minus 10. Gives me 90, and here we solve for x by adding 10. I get 5x equals 100, and if I divide by 5, I get x equals 20. So again, we're just finding the value of x, which in this case ends up being 20. Number 4, we have 68 degrees, y degrees, 4x minus 2 degrees, and 30 degrees, and then nothing on the bottom here, which again, here from C to D and A to B, we have a vertical angle across from here, so we can say this is also y. So how are we going to figure this out? Because I can't add x and y without and not be able to figure out a single variable. Fortunately for us, we have vertical angles here. We have from A to our corner to C, and we also have over here. This is the vertical angle. So again, vertical angles are congruent, meaning they are the same. So when two angles are the same, all I have to do is set them equal to each other. Now on this side, it's a solid 68 degrees. But over here, the vertical angle is composed of 4x minus 2 and 30. So this is the equation. 68 is equal to 4x minus 2 plus 30. So first things first, we're going to combine our like terms. So we have 68 equals 4x plus 28. We'll subtract 28. So we get 40 equals 4x, and now we're going to divide by 4, so we get x equals 10. Now what we have to do is we have to figure out the value of y. So we know that this part here is also 68 degrees. Make that a little better. So we know C to D is a linear pair, so 68 plus y is going to give me 180. So this is a one-step equation where I just have to subtract the 68, and I get y equals 112 degrees. So finding x was a little bit more involved. Number 5 is pretty involved. I'm going to skip number 5. Number 6, we can do number 6 here. So again, it's similar to up above where we have vertical angles and non-adjacent side or adjacent angles that are not linear. So there's a, let's see here. So here we have x minus 11, which means this is x minus 11. This is x minus 10, which means this is x minus 10. So now all of our angles are now labeled. Now here we have a linear line, meaning if I add up these three angles, I'm going to get 180 degrees. So I have 3x plus 6 plus x minus 10 plus x minus 11 is going to give me 180. Combine like terms, 3x plus x is 4x plus another x gives me 5x's. 6 minus 10 minus 11 is going to give me minus 15 is 180. So I'm going to add 15. By doing that, I end up with 5x equals 195. And if I divide by 5, I get x equals 39. So by x equaling 39, again, I want to look at the points that deal with letter y now, because I found the value of x. Now I still have to deal with this contentious y here. And again, the same thing applies. If I add up the three angles, I get 180 degrees. So here we have x minus 11 plus x minus 10 plus y is going to give me 180. Well, we already know that x equals 39. So all I have to do is substitute it in. So we have 39 minus 11 plus 39 minus 10 plus y gives me 180. So if I add them all up together, I get 39 minus 11 is 28. And if I add 39, I get 67 minus 10. And that's going to be 57. So I end up with 57 plus y gives me 180. Subtract 57. And I get y equals 123. And then it's pretty much the same thing on the other problems as well. Whether they're complementary like they are in number 7, adding vertical angles, creating, labeling vertical angles and setting them equal to 180 or 90 degrees is really up to what is given in the diagram. And that is the introduction to the different types of angles as well as vertical angles and their congruent relationships.